This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. The range, quartile and interquartile range are measures of variability or spread of a set of data. The first measure we will look at is the range of a set of data. The range of a set of data is the spread of the data. It is the difference between the largest and smallest values. If we are given a set of numbers, say 7, 12, 2, 19, 1, 54, 4, 8, and 8. To calculate the range, we subtract the smallest value, in this case 1, from the largest value, in this case 54. So the range is 54 minus 1, which gives us 53 in this case. In other words, we're subtracting the minimum value from the maximum value of a dataset. Please see the video on the median before continuing. Previously, we learned that the median is the middle number of an ordered dataset, or it is the number that has 50% of the data values larger than it and 50% smaller than it. The median can also be called the second quartile. For quartiles, we are going to continue to use an ordered data set similar to what we use in the median. The first or lower quartile is the number that below which lies 25% of the data values and above it lies 75% of the data values. It is also referred to as the middle number between the lowest or minimum number of the dataset and the median. It is the median of the lower half when the dataset has been divided into two halves by the median. In comparison, the third or upper quartile is the number that below which lies 75% of the data values and above it lies 25% of the data values. It is also referred to as the middle number between the median and the maximum or largest number in the dataset. It is the median of the upper half when the dataset has been divided into two halves by the median. Let's take a look at an example. If we have a set of numbers 2, 4, 5, 5, 6, 9, 10, 12, 13, 14, and 16. What is the lower or first quartile? The first thing to notice about the set of numbers is it is an ordered set of numbers. We will use the definition that the first or lower quartile is the median of the lower half of a set of numbers when the set of numbers has already been divided into halves by the median. So to start off with, we need to know what the median of this set of numbers is. Quickly going through this, the median of this set of numbers is 9. So the median equals 9. Now, looking at the lower half, this is the underlined range. The median of this set of numbers is given by 5. So the lower or first quartile for this set of numbers is 5. Sometimes this is also called Q1. Now let's look at the upper quartile. So for the upper set of numbers, between 10 and 16, the median is given by 13. So the third quartile or upper quartile for this set of numbers is 13. This time we can call it Q3. We could also use a formula to calculate the first quartile and the third quartile. We could also use a formula to calculate what position the lower quartile is in. So this formula says that the lower quartile, or Q1, is in 1 over 4 times n plus 1, where n is the number of values in the data set position. Filling into the formula, we get a quarter times n, which is 11, plus 1. This gives us 12 over 4, or the third position. So the third position in our data set is 5. So Q1 is equal to 5. Similarly, the position of the upper or third quartile can be found using a formula. This formula is given by 3/4 times n plus 1, where n is the number of values in the data set position. Filling into the formula, we get 3/4 times 11 plus 1, which gives us 36 over 4, or the 9th position. If we count up, the 9th position in our data set is 13. The last thing we will look at for this session is the interquartile range. This is the difference between the upper quartile and the lower quartile. The interquartile range, or I will abbreviate as IQR, is equal to the upper quartile minus the lower quartile. In the previous question, we had an upper quartile equal to 13 and a lower quartile equal to 5. Filling into this, we get that the interquartile range for the previous question was 13 minus 5, which is equal to 8. That concludes this session.